Welcome to another teardown video. This time it's another XY plotter. I just love it. This one is from ABB and the model is called SE790. It's a classic analog input XY plotter. So that means an analog voltage input will move the XY, and there will be a pen that will draw your curve. So that's actually the main feature of this product. I think this can also do some time, so we can repeat or we can start, and it's a little bit difficult to move this one. And I think there's probably also a paper holder feature in this one, so I'll get back to that if that works. I didn't power this up yet, so it's going to be interesting in a second to see what kind of cool things there's in this one, or if there's any smoke left in it. Let's see the rear side. It does. Oh, look at that! Extra bonus gift, thank you. This is probably not so good. Any more gifts? Cool. So that will be the two analog inputs, and there isn't any other cool features installed in this one, so this will just be some start, stop and reset and voltage is right, and let's plug it in and see if there's any kaboom. And we got AC input, 0 watts, and ooh, what the heck, that was fast! 9 watts. Ooh. What? Hello? Is that it? Oh. Okay. So that's great. So no. Okay, so X can actually do time. And pen moves the pen a little bit. But what? How can I get the A times 1? Ah, look at that! It's me I'm just the dumbest muppet. Look, X. Okay, now we got X, right? Yeah. Happy. And if I'm okay, it's the same. So that will be okay. It's alive. And it seems like it's really, wow, this is nice and stable. I am impressed. So it looks like this will do, so that will be centimeters, 28 by 18 centimeters, and that is a standard, oh, it's sticky. Off. So that is a standard A4 sheet, and now it is not so. Okay, now it's not sticky. It is static discharge or something like that. So now it's not so. Let me have it here. If I put a chart on, yeah, sticky as. Oh, can you hear it? And that is the fantastic thing about those static paper holders. So you never need to use tape and stuff like you had to use in the old ones. Chart. I can't wait to try and input something, and that is now. I really think we can call this a big success. This thing is moving. I think we're ready to find a pen for this thing. And luckily, I just did a design for a pen, and it looks like somebody made a nice adapter for this one. Is this a standard tool you can buy for this model, or is this somebody who made an HP pen adapter for this ABB? Because that is really cool, because I kind of made a design for HP pens a week or two ago for my HP printer or plotter. So I hope this will work. It looks like this one is a little bit too thick. So how is that compatible? That it's not completely perfect, is it? Because of the thickness here. But I hope it will work. Could have been cool if it worked. Let's try and see how fast this can go. So this is 0.1 hertz. And let's crank it up a little bit. 0.2 and 3, 4, 5. Okay, that looks like it's easy to do that. So this is 1 hertz. Still going between 4 and 16, right? How about 2 hertz? See, it's less. Okay, so less than 1 hertz, definitely. Let's go down to a half. Yeah, okay, 4 and 16. So there, about 1 hertz maximum. Oh, that's pretty cool. Let's test the same with X. See, this is 0.1 hertz, and see it goes up to 22 and down to 10. All right, so let's crank it up. 500. So this is almost the same, isn't it? Okay, 1 hertz. No, it's a little bit less, right? Okay, so it's 0.5 hertz if you want this to be accurate. Wow. But that of course applies to sine waves. So if I'm trying to show a wave that is not a sine wave, of course I need to go a lot less. Also, what I found out about the input, the 2 grounds, they're floating, and we got 1 mega ohm of input load. So that is super great. And it says something about 250 volts maximum. So that if you've got 10 volts per division, yeah, okay. Well, that's pretty good. Let's put in a pen and see if it works. So I 3D printed a new pen adapter, and it kind of worked for this one too. I need a little bit more weight because I'm using ball pens. But if you note how accurate this one is, it hits the exact same spot over and over again. This machine is just amazingly accurate. Wow, look at that. Completely stable and fantastic. I am impressed. So what I'm doing here is 110 millihertz and 100 millihertz from the same generator. So that means every 10th time of a sine wave, there will of course be a hit again. Huh. Amazing. Now I let it run for like 10 minutes, and it's just keep drawing again and again exactly the same lines, and it hits so accurately. It's just amazing. And there's no noise or no jitter or no regulation problems. It's just a total winner design. I think it is time for teardown. So this is the internals. I removed a very, very thin plastic bottom plate. So now we can see the internals. So this is mains input. I believe some of those wires goes to the on-off switch and then comes back to the mains transformator. That is probably all the different voltages from the voltage selector. And that will be the connections to the static paper hold. And they go somewhere else. One of them is connected to the transformator, so that is a little bit funny. So that will be the feedback pot meter and a very, very nice DC motor. And let me see if I can get a little bit more light. See? So that will be one axis, and let me see if I can see. So that is how it is, and it looks a lot like those two parts. They're identical, except one motor here is a lot smaller. But of course the X and Y axis doesn't need the same kind of power, I guess. So that is really the DC power supply. Those three wires are probably those three wires, plus minus 15 volts, and then everything goes into the front panel. I believe the rest is here. Let me see how we get in here. That was real fun. It is the side panels you need to take off to get access to everything. And look, steel wire pull system. So this is X and also X, and it goes in here. Ooh, why can't we get light in there? So there's some sort of a stop. But how is the Y-axis mounted? Because that goes... That's a little bit funny. Let me see if I can figure that out. It's full of all sorts of funny stuff down there. What is that? I would really like to see if I can pull this apart. So the aluminium frame here is in one piece, so I can't really get in here and have a look. And if I take this out, it's probably gonna fall to pieces. And then I don't know if I can fix it again. Maybe I can take the bed off, because that is with some of the screws, so that should be maybe possible. I think I will try and see if there is a way to do that. Also, I found out, so this is the Y-axis, and look, it's just stick it in here. Can we maybe? Yeah, we can. So that is the motor controller. And the different pots. Okay. So it's a multi-turn. Just like that, directly onto the PCB. I mean, they have done everything a lot smarter compared to previous plotters I have seen, where it's just full of really, really complicated electronics and mechanics. I'm not sure I'm too happy about that one. Is touching. Okay, we got some more. Okay, that is the Okay, we got the full bridge motor controller. It's a half bridge. Yeah, of course, because it's running off plus minus 15 volts. So of course you only need 2 transistors to drive the motor. Aha, that is nice. And I believe the next module, so the X module, is exactly the same. You can pull this up as well. And then we got the timing module. We need to pull that out the other side. Yep, look at that, it's exactly the same. So that is just how it is. The wires goes in here. Super, super easy. I mean, this is real easy and cheap to manufacture. That is great. It's just a 2-layer PCB, and why are we having this board here? Okay, so that is for that switch. I don't know about that, but that is how it's done. And this is just all op-amps, purely analog. That is what it is. Cool. Oh, now I figure out how the wire system works. So this is the y-axis. See? So it goes here and then up on each side, this wire. And then it goes in the middle and is connected to this point, and then the other wire continues up and down and is also connected in the other side here. So down here is the other end of each wire connected and fixed. So that means no matter where the X position is, see, Y is going to stay unchanged. So see, Y is here, unchanged, and X can move because of the way that the wires go across exactly here in the middle. That is pretty cool. And now we are in on the other side, the on-off switch. I think we can pull out this, and yes, it's not that. Ooh, there's a component here that I kind of pulled, and the wires goes a little bit. Here it is a little bit too messed up. I think if you uncut the wires here, you'll be able to see this module, but there isn't really anything fantastic to see here. It's exactly the same. This is just some timing stuff that will perform a sweep, and then you can just connect that sweep into your x-axis. So that's basically what it is. See, this sweep is now output into the x-axis with different timing parameters, or else it's just your input x goes to the x-axis. Super, super simple and really smart way to do it. I found one thing to complain about in this really, really nice unit. I hope this has something to do with a repair or modification or whatever somebody did. Look at this soldering. Is this done correctly? I'm not supposed to do that right. Let's see about this one. So that's alright. So I guess this one didn't have a good connection. But I don't know. I need to repair this. This is really bad. the 3 different windings, secondary windings, as you see here. One for the timer, one for the X, and one for the Y. They're completely individual secondary windings of the transformator. Only the center point is connected with a capacitor to chassis. And this is because the inputs there are of course floating, so you can connect them to whatever you want. I wanted to explain a little bit more in detail about how the wires work. So I removed the cover for the Y-axis. This reveals the wires. So when I'm moving the Y-axis like this, of course I pull the motor with me when I'm pulling one wire longer and the other one shorter. When X-axis is moving left and right, the Y-axis is not moving. Okay? Look carefully what happens to the wheels. I don't know if you can see this, but when I'm moving X-axis, the wheels here, they turn. And this is because the wire is connected here. It's fixed, right? So it goes up here around. So this is a double wheel, 2 individual wheels on top of each other. So the wire goes here around this wheel and back to the motor, where it goes around a number of times up this wheel. Again, a double wheel, 2 on top of each other, and then down around the other one, and then to a fixed point. So that means when we're moving the motor wheel, we're making one wire end here on the top longer or shorter, and the other one the exact opposite, right? So this way it moves the Y-axis. I'll try to make a nice drawing like this to show the way the wires go that I just explained and just showed in the plotter. So that should kind of reveal the wires and how that works. Also, I want to show them the pen lift. See, that is actually really, really intelligent designed. So this pen can lift, right? So there's a spring, and now there's another wire that is attached here. So this wire goes through 2 wheels, and they are placed a little bit in a zigzag. I don't know how that is. Is that easy to see here? Those 2 wheels on top of each other in a little bit of a zigzag. And then the other end of that wire goes to like a relay or solenoid. So when you activate the solenoid by pulling the wire harder, see? The pin is pulled down. And of course, the length of this wire is constant, so that means when X moves left and right, the pen is not affected by that. Only when you pull the wire. It is just the most genius and simple design ever. to get access to the covers, all you have to do is loosen those through 3 screws, and then you can lift up the covers. Of course, it's exactly the same with the bottom cover. Again, 3 screws.